So without any further ado, I'd like to introduce our panel to you today. Very special day. Tony Smith, it's your birthday, Tony. So many happy returns from us all. I'd like
Very kind of you. Thank you very much.
If I knew how to do it, I would open up all the microphones and we'd have a mass chorus of happy birthday. But
best you don't.
As I have already sung to you today, I think you've had enough of that.
Oh, I'm having a good day. Yeah, this is one of the highlights this hour.
Good. Well, as you know, we sent it was quite funny earlier today. We sent Tony a small gift, and the delivery company said to me, because it contains a little bit of alcohol, the delivery company said to me, they said, will Mr. Smith, could he please present his the delivery be between I think 11 and 12, and could Mr. Smith please bring proof of age to the when he answers the door, because our delivery agents are only allowed to we can't deliver to underage addresses, people's addresses. So I'm pleased to say that, Tony, you did manage to get through security and get your present, did you? Your gift.
Yeah, I think they decided I was over 25 years of age without any.
Well, luckily you had your passport with you, so that was fortunate. So as I said, Tony Smith, world-renowned inventor of the PAPI, happy birthday from us all. Keith is with us today, independent consulting engineer and trainer, recognized worldwide for his airfield lighting expertise. And Stuart Ford, independent airfield lighting specialist, founder of the ACE training, in North America, which has become the accepted standard for all airfield electricians in North America, under the auspices of AAAE. So welcome, Stuart. And
thank you.
Myself, Robert Shapton, I'm managing director of Tailor-Made Systems and TMS Training Solutions, and the MARMS company that I hope you may have come across in your airfield lighting world. So without any further ado, I'd like to kick off today's presentation by introducing Keith. The topic of today's webinar is maintenance best practice. As you'll discover, such a simple title, a simple heading, has a somewhat more involved answer. But luckily, Keith is with us today, celebrating his 60th. This is actually his 60th year since this week, 60 years ago, Keith started his first job in the aviation industry. So you're getting a lot of expertise packed into this webinar. So thank you for that, Keith. And Keith will explain maintenance best practice in clear and simple terms to us. Over to you, Keith.
Yes, hello everybody. Good morning, good afternoon, good evening, wherever you are, based in the world. 60 years since I started as a young teenage electrical engineers training in as an aircraft engineer, then migrated into airfields, and so it was a lot of water under the bridge, as we would say. But maintenance best practice. What we cannot in 1 hour have a seminar and with a Q&A session, which it's going to be quite extensive, hopefully, is that we can't cover everything associated with how and the detail. So we are going to, in the future, going to have additional webinars with some case studies, etc. But we'll talk about that later. But maintenance best practice, what does it actually mean? It means making sure we've got operational performance of our systems and on the runway, on the taxiway, minimizing the possibility of failure or the deterioration of light output. And there are many, many factors which will affect the light output. And why? Safe aircraft operations. They are our end customer for the traveling public, because my family, your family, everybody wants to travel safely. And that's what it's all about. So next slide, Robert, please. So where do we come from? Well, ICAO have been adopting and carrying out a lot of safety oversight inspections globally to around the authorities and the airports. And when they do their safety oversight of the authorities and the airports, they have established that they have 8 critical elements, which is a potential problem area. And what I've done is just extracted out of those 8 critical elements, and they're defined in Annex 19. Then I've extracted 4 of them. Critical element number 4, the qualification of technical personnel. Critical element 5, the technical guidance, the tools and information, and critical element 6, the licensing and the certification obligations that exist. Now we have all 8 are equally as important, but I've just took that out of those 3, and which really, you know, as we are talking about best practice, then yes, we need to have qualified technical personnel, we need to have tools, and we need to have spares, we need to have the products need to be of a certified product that we're using, etc., etc. Next slide, please, Robert. So maintenance, it's a critical element. We've got to maintain. As soon as we install a lighting fixture out in the field, at that moment in time, we walk away, it will start to deteriorate in some way. And so the activities associated with maintenance is that, as I said, using the correct tools by competent personnel. And it will, if we maintain our tools and equipment correctly, then the life expectancy is increased, and it performs in accordance with its design. So we're now into these evidence-based world because of digitalization. As we move from the analog world to the digital world, we're now into being able to look at our equipment and see whether or not and what level of performance that they are performing at. And so I've just called it evidence-based. Now in ICAO, differential-based maintenance is what it's all about. So next slide, please, Robert. So, but remember, an airport is a vast area. It exists, it's a big field, and a big field with potentially multiple runways, multiple taxiways, multiple parking positions. Whether or not it's a military aircraft with weapons, whether it's a cargo aircraft with lots of different cargos, or whether it's a passenger carrying. So whether it's civil, military, everything principally is the same. That we have runways, we have taxiways, and we have the parking positions, the aprons, they call them the ramps, different names, but that's what we have. And the infrastructure itself has been under increasing pressure with traffic density, and we've had COVID, and there's been vast areas of airports being used to park up the aeroplanes while we've been unable to travel over the several years, but we're now going back towards the traffic density levels again, thankfully. But of course, in all that, we have the equipment, and engineering has suffered. Engineering has suffered because no aircraft flying, not using the facilities, so and the facilities being used as a car park, basically, and the persons associated with maintaining the airfield then have either been laid off for a period of time or had hours that reduced. So there's been a pretty difficult period of time, but we are returning back. Next slide, please, Robert. So we're into this world now. People call it Airfield 4. Where's that Airfield 4 come from? What is it? Well, basically, it's this move from the analog era to the digital era. And we've gone through in industry, say industry 1, is industry 2, industry 3, and now we're in industry 4. We've adopted it in aviation. So we had Airfield 1, Airfield 2, Airfield 3, and we're in this digital age now in Airfield 4. So what is it? Let's move on to the next slide, Robert. It's this digitalization age. And the key issue is that we have real-time communication capability today. So the latest advancements in wireless or the wireline connectivity with artificial intelligence and maintenance using robotics, etc., in the whole of industry has changed dramatically over the last few years. So Airport 4 is about this migration from the analog to the digital world in all elements, whether it's control, whether it's power, and the lights themselves. So next slide, please, Robert. So when we're talking about this, this digital transformation, then of course in AGL, when we look at AGL, then there are 3 functional blocks of airfield ground lighting. Aeronautical ground lighting is the formal name. So we call it AGL. Some people call it airfield lighting. So that's why I put AGL stroke AFL, depending on which part of the world we're in. But when we look at this digital transformation that I'm talking about, if we talk control engineering, so we have a control system for AGL, so control system engineering. We have the power unit, and so there's that block associated with the power unit. That's incoming electrical power, standby power, and the unit itself of a traditional system, AGL system, which is the constant current regulator. There are other technologies, however, associated with the standard AGL as a complete system. But at the end of the day, it's a light fixture out in the field, several kilometers away from the power unit. And the controller is the air traffic controller with the control system several kilometers away from the power unit. So we have this change of technologies. In each of these areas, there's a change. So what we're talking today is more about the building blocks of how we are moving and the things that are affecting ourselves in maintenance today. So the best practice. What is maintenance best practice? Well, we're leaving behind the analog age and moving into the digital age. Digital age, real-time reporting, real-time operations. Next slide, please, Robert. So pulling out that the key elements associated with this era that we're talking about. So we need to be able to capture data. So what it's all about in any measurement system of looking at maintenance, you capture data, you analyze data, and you present it. We've always done it that way. But the thing was, we did it in for example, when we're presenting data, we've done it with paper-based systems. Now we can do it electronically, and we can do it in real time. But you've got to capture data accurately, reliably, and to be able to analyze that data that you've captured, analyze it in real time, and analyze it efficiently in real time. Then you take the data that you've analyzed and say, who wants to know about it? And who wants to know about it? The end user wants to know about it. The operator who's managing it and operating it wants to know about it. The people making the decisions in administration want to know about it. And so does the maintainer want to know about it. So depending on who wants to know data, can we give it to them on time, efficiently, in real time? Yes, we can. And that's what we're talking about when we're talking about Airport 4. We take the whole package and then say, we can look at how a particular lighting system performs. Is it fit for purpose? Is it meeting the standards, etc.? And if it is not, can we identify it? And then etc., etc., going on like that. So next slide, please, Robert. So when we're looking at Airport 4, as we want to call it, it's all about managing the asset. So what is the asset that we have in, and we're talking Airfield ground lighting here, AGL. And when we're looking at the lighting, we're fundamentally looking at the light output. So what will affect the light output? What will affect the fact that light output is not being achieved in accordance with the recommended, the standards and recommended practices, Annex 14 and the ISO Candela diagrams. So I put these 4 areas that we look at whether we do an inspection, whether we do an audit, or whether we just look at it from a management perspective in terms of looking at maintenance. We look at the installation of the material, what we've got in the field. Have we got the correct equipment for doing the function, be it runway, be it taxiway, be it apron lighting? Has it been correctly installed and set to work? And the criteria that accepts it, was this acceptance criteria there? So this is where the regulator comes in and then said, yes, okay, demonstrate, show me, demonstrate. I want with a big tick off list, etc. And then say, yes, it's fit for purpose. You can put I can license you now to use that system for safe aircraft operations. But to achieve that, remember what I said, as soon as you put equipment out in the field, then it will start to deteriorate. Facts of life. If you drive a car, the car will deteriorate, so you have to service it. Our equipment in AGL is just the same. You put it in the field, you get it all working, it's been designed and installed, commissioned, it meets all the standards. The moment we switch it on and walk away and it goes into its operational life, it starts to deteriorate. Facts of life. So we need tools and test equipment and workshop facilities, etc. We need spares, we need technical manuals, correct technical manuals to enable us to do that. And we do this maintenance in a proactive way. So we plan it. We have a program associated with scheduled inspections and tests just to keep that equipment in an operational and good condition. But to do this, we need people who are adequately trained and deemed competent. But because of the nature of AGL, it's an electrical system at the end of the day. And in electrical engineering, then it's pretty clear that we have a current, we have a voltage, and we have a resistance, which we know because it's AC, it's actually an impedance out in the field. And so we put current, impedance, and voltage together, then it's potentially dangerous. And where do we put it? In the field, we put cables in ducts or directly buried. We've got transformers out there, and we've got connectors out there designed to be watertight, but all waiting to fail. So if I've got 60 lights, I've got 60 transformers. If I've got 60 transformers, I've got 120 primary connectors, and then I've got the secondary connect. So what we have out there to be able to illuminate the lights correctly in accordance with the standards and etc., then we have to put a big pressure, a voltage onto that circuit to drive the standard system of 6.6 amps. Now, there are other systems out in the marketplace, so not everybody uses a constant current system, and there are parallel systems, there are lower current systems, etc. So other systems are available, but most of the world are standardized on a 6.6 amp series circuit system. So when we're looking at all this, we need to have people who understand and know the dangers. And the key issue for the dangers is that voltage burns, current kills. 10 milliamps a human being can't let go of a live electrical circuit. We've got up to 6.6 amps potentially in our field. And to be able to push 6.6 amps right the way around many kilometers of circuit, then we need a voltage, a high, a relatively high voltage. That relatively high voltage is up to 5,000 volts. And at 5,000 volts, if you touch a circuit that is live and on a 30 kVA CCR and fully loaded, then if you touch a live circuit, that will burn you. It will burn you. And unfortunately, if the current goes through you, it will kill you. It's as simple as that. So this is what Airport 4 is about, managing that. Next slide, please, Robert. And so how are we now starting to look at the technology changes? So let's have a look at one or two little technology advances that exist. Communication technology. We no longer have copper wire, from in the control system, from the air traffic controller down to the substation, the switch room, the vault, whatever we want to call it, where the CCRs are. Then we communicate using the modern, like fiber optics, for example, a fiber-based system. We don't have, we have data bus communication, etc. But now we can go out in the field and measure lights, the output of lights, do different things out in the field. How do we communicate that in real time? The GPS. Well, the GPS is actually not that accurate, from our perspective. So we want something which is a little bit more accurate than a GPS. So we have a local network, which is using RTK technology, real-time kinematics, which is down to location of centimeters of accuracy. Now that meets our purpose, but we need to be able to communicate that, the information of what we capture in real time. So a photometric trailer, for example, measuring the light output, we need to communicate. If we want to torque the bolts, and maybe you will move on to the next slide, Robert. This is the equipment associated with the RTK. So you have a rover module, and we have the base station. So whatever tool you've got out in the field, whether it's a vehicle or a trailer or an electronic torque wrench, you have a rover module that is communicating in real time securely with a base station, which then will ensure we get the correct accuracy of location of a lighting fixture. We have evolved the location of a lighting fixture by having RFID tags in the ground, which is the most accurate way. Now we have the belt and braces, the backup capability of accurate GPS type signals. Next slide, please, Robert. Here I mentioned earlier, the torque wrench. Well, the torque wrench itself, for checking the tightness of the bolts that we use to secure our light fixtures out in the field, and specifically in pavement inset light fixtures that are on the taxiway or on the runway. And so there's the new generation of electronic torque wrench. We've had the mechanical torque wrenches, we went to the electronic torque wrenches, but now we're in the advanced torque wrench era. And so that, and because it's a measurement tool, then of course it does need to be calibrated periodically. So the ability of the new generation of the electronic is not only can it communicate accurately, communicate using a mobile phone concept, as it's shown in the lower picture here, and when we come to actually being able to calibrate it correctly, the small sensor, you don't have to send back the whole torque wrench anymore for calibration. Then when I say send back to the calibrate to get it calibrated, it's a small module. So no, we've moved forward in the hardware side as well as the communication side. So this is just an example of how we're moving into the world of digitalization in a more advanced way, to meet our requirements. Next slide, please, Robert. So what do we do? Do we have a choice out there? Yes, we do have a choice. We can just stay with our old paper-based records, etc., in the way that we've done it over many, many years, which have served its purpose. Or do we go to some kind of expansive and overall enterprise asset management system, shortened to AEM, AEM? And there are these systems, these great big systems that can manage and take vast differences of volumes of data. But are they dedicated for the airfield? The answer is no. So we have now the airside computerized maintenance management system, and you will realize that as we go through that from a TMS viewpoint, and there is the MARMS engineer system and its associated dashboard. And so we really do need to have this airside, which is we've got the tools to capture data, and I've shown like an electronic torque wrench, which exactly, we can actually put the information in about the light fixture, so it's an automated system that the operator cannot make a mistake, because the tool will not allow you to make a mistake without going into the detail of how it works. So we can record that information in real time. So we've captured the data, we can analyze the data in the MARMS engineer or the CMMS, and then present it through, onto the wider EAM system if needed, or locally manage it in the maintenance department. So next slide, please, Robert. So all I'm saying is that to you is that, this is the way forward when we're looking at maintenance best practice. When looking at maintenance best practice, then of course we are talking about being able to capture data, analyze the data, present it in real time. Next slide, please. So this is how it's been developed. When I say we, I mean we collectively. A lot of people have been involved in associated of the MARMS CMMS, and it can do a whole range of functions. And but at the end of the day, what I will say here, look, we can add the electrical information of insulation resistance values, continuity resistance values, etc. Operations will have the results that the system is performing. So the airfield operation department has a handle on what's going on in real time. Air traffic, the controller they will know, oh yes, I'm fine. I know I've got a system that works, because they've got not only the back indication, but we can also provide that information as a to the air traffic control. Management of the airport can have, selected information sent back, which links in with the financial side, and also the later introduction now is that with the latest reporting format of the civils, etc. So we can integrate the mechanical, the electrical, the civil, as well as the photometric into a MARMS CMMS. It's all available today. So, and the important thing is, with a MARMS system, it is totally independent. It's not linked to any AGL supplier. And because if you have a system that is linked to a supplier, then you have commercial interests start to come into the equation. So from that aspect of things, the independent side is an important aspect. Next slide, please, Robert. So I mentioned differential maintenance. Well, what it's all about is performance-based maintenance, evidence-based maintenance, the ability to be able to collate, capture data, analyze the data, present the data in real time. So this is now a nice little thing, and an IKO in the Annex 14 refers to the whole package as differential maintenance. And differential maintenance as a name that was actually evolved by the former owner, the former inventor of this, together with Tony Smith, Vernon Taylor, where tailor-made systems came from, and of course the modern way we're capturing is measure, maintain it, monitor it, and then it enables us to manage it. And I think it's as simple as that. So we have MARMS engineer as the CMMS, together with its associated dashboard, which you see on both sides pointing in. Next slide, please, Robert. So what's happening over the last 10, 15 years? Let's take an example of what's happening. We've migrated from tungsten halogen to LED. We've transferred in CCRs, in the 6.6 amp system, from a thyristor to IGBT, transistor-based technology. We've introduced more advanced and reliable individual light control and monitor, and including in some cases, having that in the light fixture itself. We've got this, the reliability of the communication and the security of communication technology today, and the real-time associated with that. We've also got traffic density increases, and now they are returning back after COVID and surpassing the previous communication, transportation and traffic density requirements. What has not changed, however, the lights still get dirty in the field. So cleanliness is one thing which has not changed. In fact, cleanliness is getting dirtier because we get more traffic density. So this cleanliness is a function that stays with us. The fixture security of the bolt and the torque, more aircraft bouncing onto the runway, for example, to land and to take off, is going to put more stress on the pavement, which more stress on our light fixtures that are in the pavement. The continued use of paper-based maintenance processes and recording. Who of you out there and airports around the world have anything associated with electronic recording, etc.? Not so many. We're still in that era, and we still have an issue with the training and the competency justification of AGL personnel. You know, I've been here for 20 years. When did you do last course? Oh, I haven't done any courses. It was all on the job learning. Well, it's not quite as as simple as that anymore. We have to justify, and that's the key issue, justify competency. That's what the standards say now. Next slide, Robert. So one era is, let's take that one era I said about earlier, the migration from tungsten halogen to LED. So we have moved, and in the US, there was a huge through the ACRP on the LEDs, but LEDs have been around for a long time, but it's a while. It was only 2002 that we introduced LEDs practically in an airfield, and that was taxiway edge lights. And then it was 2012 before we got runway related lights. So we are moving forward all the time. So let's take LEDs. Next slide, please, Robert. Let's just take LEDs themselves. What effects? And this is not my slide. This is taken from Osram, who are one of the world's leading suppliers of LEDs. And when you take an LED, humidity affects the light output, temperature, chemicals, current, voltage, mechanical forces, and light. So do we have all those in a 6.6 amp AGL system? Yeah, we do. We have all those 6 points. Next slide, Robert. So when we're looking at an LED, and we look at, there's two types of failure that happens. It's early life, or then the gradual deterioration. But then it has its midlife, which is called the spontaneous failure period. So there's extrinsic reliability and there's intrinsic reliability with LEDs. The extrinsic is the phases 1 and 2 that is shown on this slide, but the intrinsic is basically the life expectancy associated, where there's a gradual deterioration of brightness and color, etc. Next slide, Robert. And this is really a follow-up to what I've just said in the previous slide. So this is like showing the deterioration graph and where the economic life and an LED is. We are told, and I remember many years ago when we introduced the first LEDs, it was saying next time it showed a person installing an LED lighting fixture onto a runway, and the statement was the next time we have to manage and maintain this, his baby son will be at university. Well, we know that's not materialized at all. And so the early failure period is pretty quick in its early part of life, and it's usually something to do with manufacture or component problems within the driver, etc., within the LED package itself. So that's the early failure. Then, of course, we have various random failures for various other reasons, and then we have the wear out period, and that period is defined as somewhere in the region of 50,000 operational hours in AGL at 6.6 amps. However, we know that has not necessarily materialized because there's more electronics, and the electronics, the light fixture itself is an aluminium alloy structure, and we got these electronics in the field, so it is subject to external electrical influences, and there is no Faraday cage as such. So if you're an electrical engineer, you will understand what I'm talking about. So the LEDs this has been an interesting period of life over the past 10 years, 15 years or so. The evolving move from tungsten halogen to LED. One example, just one example. So moving on, Robert. So going back to our CMMS, real-time recording, reporting, demonstration, and justifiable records is an important factor when we look at all the potential areas of cleanliness in the field, structural damage. If we can look at the electrical, the insulation resistance values of the 6.6 amp system, for example, etc. So we can capture that. We're back into our MARMS CMMS concept of what is existing today. Next slide, Robert. So looking at standards, what do the standards say? And do we on airports globally implement these requirements? Maintenance program, and it shall be employed as a preventive maintenance program. And there are 3 key issues that are recommended that we do to achieve that: the visual inspection and in-field measurement of the intensity, beam spread, etc. The control, switching it on, switching it off, different intensity levels, and looking at the electrical characteristics like quality of the electrical circuit, etc. So airports have a legal responsibility in this respect. So next slide, Robert. And there are the recommendations of how we can achieve it. But basically, to summarize that, I've put on this slide at the bottom, right, we can measure the light output. So we have tools to measure the light output, and it's got to be very quick. It's got to be a mobile system because access. So it needs to be mobile and be of sufficient accuracy. And I would say repeatability. And the frequency that we measure will be according to the results, not once a month, not calendar based. It's according to the results. So that's next slide, Robert. So coming back to my CMMS, the MARMS, it's a cloud-based system, so it's accessible, so in real time, and it's back to the old measure, maintain, monitor, and manage. And what does it say? It helps us to decide when we're going to do maintenance, what we're going to do, and where we're going to do it. Because we may be doing maintenance with this limited access issue. We may well be doing more maintenance than we need to, or we may not be doing enough. So we measure, we maintain, we monitor and manage, and that enables us to when, what, and where. Next slide, Robert. And so we need to present it. So the dashboard is configurable dashboard. So whatever information we need to put on, we can put it into a simple dashboard system, and you can then drill down into the individual systems to see what the status is, whether it's electrical, whether it's mechanical, whether it's civil, or whether it's just pure photometrics, etc. So the whole range of this CMMS is into this digital world, this Internet of Things, and reliable cloud-based solutions of capture the data, analyze the data, present the data. Next slide, Robert. And this is an example right on the thing. This was a trial that was done in an international airport, and the trial was associated with looking at the lights, measuring the light output, establishing whether they were unserviceable, that 50% criteria that we all know about, whether that needs maintenance, the criteria of the 70, between 50 and 70% of light output, and then whether they're serviceable. So we use colors: red, unserviceable; blue, needs maintenance; green, above 70% is serviceable. And the actual figure, so this spreadsheet just shows exactly. But what is interesting, you'll see like a big yellow, it's an orange line, and I can see it on my screen as a yellow line, but it's a big orange line. And there is that prior to the right-hand side of this spreadsheet, you'll see lots of reds. And then the column 5 is all red. That means those lights with that ID on the left-hand side, then those light fixtures were all unserviceable, below 50%. And therefore, we cleaned all the light fixtures. And in cleaning the light fixtures, look at the improvement in column 4. And then periodically, we cleaned again and look at the improvement. But there were still some failures or some lights that needed replacement, but there were created by other factors other than cleaning, which shows cleaning is one of the high priorities. So there's two main issues in that we need to record and check and do it in real time with this modern CMMS, this digitalization period of life, is to be able to say, can I demonstrate that our lights are working according to standard? And we can now, and this demonstrates that we can do it. So next, if anybody's got any questions, but next slide, please, Robert. And that is where we're going to go beyond in the next webinar, is to, in webinar 32 on the 30th of May, and we will look at some case studies. And so this has been the building blocks towards some demonstration of best practice, you know, as case studies. So this is the introduction where we've moved from our analog age, our paper-based, our calendar-based maintenance into this modern era of Airport 4. Thank you very much. So we'll go into now our quick Q&A. I think there's been a few Q&As come up, and so if you have any questions, you know, I think all four of us now back online, I think.
Well, thank you very much, Keith. As Keith intimated, when we came up with this topic, you start to actually prepare the presentation and you realize the scale of it, and hence we're going to have a second part two to this particular best practice seminar, because today was basically focused on the building blocks of evolving the best practice airfield lighting maintenance processes and procedures. But it's a very much a personal thing, an individual thing to airports, because everybody's circumstances, everybody's environment, everybody's, whether it's traffic, weather, installed base infrastructure, the people, everything plays a factor in determining what the best practice is for an individual airport. We've seen that the digital world now allows us to capture actions and measurements real time. Computers allow us to store and analyze all this information, and artificial intelligence or program-based analysis of the data you've collected enables us to predict probable future outcomes, which will enable you to determine your maintenance, your optimal maintenance programs, your best practice for the future. So, of course, all these outcomes must be in conformance with standards as defined by ICAO, FAA, EASA, and all your national bodies. And they must be delivered effectively and efficiently, because we recognize the constraints on all of our airport operations. But this can, of course, only be delivered, as Keith pointed out, if you've got the well-designed, installed, and properly tested infrastructure in the first place, and then you have the tools and test equipment that are fit for purpose, harnessing the latest, the technology changes, whether it's the new latest control systems, the intelligent lights, LED lighting, or any of the other technologies that are coming, RTK, for example. You have to have good processes and procedures up to date, based on performance and predictive maintenance techniques. You need good people, of course, who are competent and also benefiting. Even if you have good people that are competent, they need to be kept up to date. So continuous professional development is very important. And finally, they need to be all trained in the processes and procedures operated by that airport to actually deliver with the infrastructure, the tools, and the processes they have available to them. So very good excellent presentation, Keith. Next month We will be giving some real life examples about covering case studies such as an airport, how they decided to move from halogen to LED technologies, using the information gathered in using the building blocks that Keith has described. An airport choosing to move from traditional lenses to sapphire coated lenses, how they reached that decision and how effective it's been. Another airport looking at how often to clean their runway lights. How often do you clean them? Well, there's no one answer to that question. So we'll be talking about that as a case study. How
But
often?
it's also, Robert, is not just how often, but it's how to clean them.
Well,
Isn't it?
yes, exactly.
Yeah.
How often to perform photometric testing as part of your preventative maintenance regime. Circuits, civils, when to do overlays, for example, and what basis do you make those decisions, and how often, when to perform maintenance on your electrical infrastructure based on your circuit measurements. So all of these topics will be tackled as specific matters in next month, which is, I think, the 30th, I think, Tony, the 30th of May. So if you could mark that date down in your diary. So without any further ado, thank you very much, Keith. Let's go to the questions. And the first of all, there have been several birthday wishes to you, Tony. So happy birthday.
Thank you very much. Very kind of you.
You're the world out there, you know, the team out there, very much the family, the TMS Training Solutions family wish you a very happy birthday. So from all over the world, I can see. So that's really nice. And I'll pass on all your wishes individually to Tony. So good. Hello, Safe would like to know, hello, good morning. Can you please enlighten us on asset management tools widely used in AGL and airfield lighting systems? So what are the tools you come across most out there, gentlemen?
Well, I would say photometric, the tools is photometric testing, because ultimately a light fixture, it is what it is. It's a light fixture. It's to give light at the correct intensity, color, in the correct direction, etc. And so the primary tool is to measure, is the photometrics, is measure that light output for the accuracy that it's designed to do. The other tools behind that then is when the light output is not being achieved.
Yes, I see there are various control systems out there that are employed. They receive some lights contain intelligence that will record if it's a fault condition. That's one common thing we see, but of course that doesn't capture a non-compliance or unserviceability due to external conditions like rubber on the lens and things like that.
Correct.
We see the photometrics now. We can now photometrically measure apron and stand lighting and PAPI lighting, of course. Too often we come across airports that have a policy of replace on failure of lighting, which does not comply with the standards, because failure occurs long before the light fails completely, because you're talking about the visual cues to the pilots, not to somebody standing on a runway in front of a light. And I would advise, I heard an excellent presentation from Lethbridge, Canada last year, where the airfield lighting manager was enlightened enough to be able to, they had a training school, I think, there, and he managed to take his airfield operations management up on a light aircraft to show them what the visual aids looked like from the air, and I use that as a basis to convince them to invest in an upgrade, which which is a very interesting approach, but I think very worthwhile. See how good your work is from the air, if you at all can possibly arrange the opportunity, because it is quite interesting, and we have some examples on our YouTube site of visual aids that have been well maintained and poorly maintained from the air, and you can actually see the lights that appear to be out as you're approaching the airstrip, and as you're coming into land and landing itself, you can actually see they appear to come on, because close up they're on, but they're not effectively on. Well, they don't appear to be on from on the approach, which is you can imagine what that would be like in low visibility conditions. I think Tony did some experimentation on that as well.
Can I say something on that, Robert?
Yes.
Yeah, that's very valuable from my experience at the RAE. From time to time, we take our maintenance engineers flying to let them see what it was they were maintaining and its purpose and how it's used. The other side of that, I would say, if there's one thing I would say don't spend money on in general terms, and that's flight inspections. I believe that they're in the analog world. We're moving to digital. We can now measure. And all of this started back in '73 when I pointed out that licensing by means of flight inspection resulted in centerline lights that had in licensed aerodromes, international aerodromes, where the centerline lighting was in many cases down to 200 candelas maximum instead of 5,000. So you've got to be very careful of what you can do. Some general information from the flying, but to manage the equipment, I would say I'd go as far as to say flight tests are useless, and a lot of things they can't. And anyway, where's the data leak? How you're dumping that information?
Well, it's a subjective view, you know. I mean, when we go into from the analog world, Tony, you quite rightly have said, you know, in the analog world, then it was the best we could do at the moment is say, oh, let's do it from the aircraft instead of on the ground. But then
now we have the tools.
Is subjective, eh?
Now we have the tools to do
yes.
accurate measurements.
Yes.
Straightforwardly, collect the data, analyze, and so on. The era of a flight check, which was the best that anybody could imagine at that time. But we have moved on. I think you've illustrated that very clearly today. There's no place, I think, for flight checks in the licensing regime at all.
I don't think the flight test companies will welcome you with that statement, Tony. But it is the reality, isn't it?
It is.
Yes.
Right. So there are a number of examples. I mean, a flight test does a lot more besides than just purely. It doesn't do. You can't do photometric checks from the air. You can't. I don't think you can measure PAPIs from the air based on my experience. That is a controversial statement, and I look forward to a discussion with anyone involved in the aviation world of air flight checks. But
from an FAA perspective, Seward, you know, and we're looking at this whole subject, you know, and we have spoke in great depth about the differences where in the ICAO world, then it's more, you know, the standards and the recommended practices only go so far. They say this is what you've got to achieve, but in the FAA world, of course, they're more specific and then say this is how you must do it.
Well, that's true. We have a lot of specific directions in the FAA maintenance documents, as to what you do when a certain number of failures occur and so forth. But as I listen to all this, the big thing that comes pounding to me is that education. We've got to educate the people to realize that this is important. And that means over in our country, in the FAA world, we've got to make sure the FAA's got to realize that they have to enforce these specific directions they give with regard to maintenance and factor it into the regulations or the advisory circulars, the engineering briefs that they make. We have to realize the issue that you bring up in differential maintenance. They sort of blanket maintenance is to the whole airfield, and you look at it the same way everywhere you look on it. Well, that's not the case. We know that there's certain areas which have to have preferential treatment because of the landing in their particular area or the traffic, what have you. So we need equipment in order to the proper equipment, photometric equipment being the greatest, I think, to determine where we really spend our resources. And the standards have to reflect that. They have to reflect the flexibility that we need. And right now it's sort of cut and dried with the standards. It's got to do this or it's a failure. Well, that may be true, but we've got to think more, and we've got to educate our people more as to what is needed to monitor these systems and how differential maintenance is so important in making the systems correct. I could go on, but I'm not going to say any more. But I think it's an education process is where we've got to start. And we've been a semi-failure in that. We got a lot of documents, but we don't enforce the documents, and we haven't educated the airport operators properly.
Thank you very much. I have a question here. From Mohammed. Says, what is the difference between evidence-based maintenance and performance-based maintenance? Where does ICAO Annex 14 refer to differential maintenance? Well, let me answer the last bit of the question first. The aerodrome design manual 91915
Part 4, isn't it?
Aerodrome Part 4 in section 18.4.9 actually refers to differential maintenance and recommends it as an approach to maintaining airfield lighting fixtures. So it's in Part 4 of the Aerodrome Design Manual. So if you want to look it up. Evidence-based and performance-based maintenance.
Well, I'll answer that one.
Yep.
I'll answer that one. Performance, you're measuring the performance of the light output, basically, and once you've measured that, you've captured that data, and you've analyzed that data, you now have the evidence. So basically, it's the same thing, So that's where there are these different names. But of course, as you've just said, Robert, the Aerodrome Design Manual, ICAO's Aerodrome Design Manual Part 4, and now Chapter 18, and the latest version used to be Chapter 17, but now at Chapter 18, then this is what refers to differential maintenance. So differential maintenance encompasses performance-based maintenance, evidence-based maintenance, and takes us towards predictive maintenance.
Thank you, Keith. Safe has asked us if we can talk some more about RTK. We actually have a webinar that was scheduled, I think, later this spring, where we'll be talking specifically about our work on RTK. Or what I can say is it's currently under development, because like a lot of these new technologies, what they can do and what they actually deliver can be somewhat different. And clearly, when you're working on an airside and safety critical operations, you need the equipment to actually work, not just sometimes, but always and reliably. So we're currently working on some solutions involving, RTK technologies. You'll have seen and presented in our presentation earlier, and we will address those specifically in detail in an upcoming webinar. Nick has asked, since TMS deals with AGL photometric measurements, also able to observe toe-ins during light fixture. So we measure the toe-in of the lights if indeed they are towed. My question is, where bidirectional high-intensity runway lights are used, can the toe-in angle be reduced? I mean, the towing angles are defined according to the standards to provide I mean, Tony, you will have been involved in setting defining the towing angles. Perhaps you could just describe the purpose they serve.
Well, the purpose, and to be frank, these towing angles were chosen about 50 years ago on a very basic thing of, well, there isn't we've got a limited beam spread. There isn't a lot of point, for example, in your runway edge lights, giving equal amount of light outboard as to inboard. You've got a certain amount of light flux. You need it more on the inboard side than the outboard side. So we'll tow them in a bit. I mean, if you made beams wider azimuth beam spreads, you wouldn't need to worry about the towing. I mean, this is practical engineering, keeping the requirements for the number of lumens you've got to use, and therefore the power, the size of your light source, and so on, keeping that to a practicable minimum.
It's a very interesting point now, particularly with LED lights and a much sharper, more sharply focused beam. I know that Seward was involved in. You were involved in the trials at Raleigh, weren't you? I believe.
Trials at where?
You've been involved in LED trials, haven't you? In the initial LED trials, Seward, and I've so I mean, with the more focused beam you get from an LED, what have you noticed?
Well, yes, the light source can be smaller. The problem with the tungsten as a light source is it could be quite a large in terms of, it isn't a point source then. There's no way. You can almost say a single LED can be regarded as a point source. A tungsten filament bulb, no way is it it's an extended source. And so, you can do things with LEDs. They have specific beam spreads and fall offs either side of that quite sharply. So, you can make a beam spread by putting a matrix of LEDs, not pointing all in the exact same direction. You can take benefit of, if you know the beam spreads, you can produce a spread beam by having a matrix where some are not pointing, if you like, 4.5, are pointing out from the
exactly.
You can do it.
So, in relation to the US trials?
Well, yeah, and I wasn't involved in the trials where we were talking about the beam spread. I was involved in the early trials where we were just converting to LEDs, and it was taxiway fixtures and that trial, and we did it with that. And the big thing there, and I won't get into that, but we did not use pulse width modulation. We used a linear changing of the DC current through the LED, and it appeared good to us when we did that. But later on, we found that changing the LED current, first of all, it probably put an LED current through the LED, which was not optimum for life and color of that LED. And so what we ended up doing is finding the optimum LED current for that particular fixture that gave us the life and the color we wanted to. And then what we did was use pulse wave modulation, which always puts the same current to the LED. We just pulse it through the LED at a particular rate, which is faster than the eye can discern. And so we vary the intensity by changing the pulse rate. And that's what I was really involved in initially.
So but I mean, I have to say that having spent a lot of time on runways and observing them from the air as well, you're modest about what you say in terms of how you 50 years ago, how you determined the beam spreads and the towing angles, because LEDs, which, as you know, have a far more focused beam than the halogen, the incandescent halogen incandescent light sources, the result seems to achieve the required aim, that it provides the visual cues from for the pilots on a distant approach. They can be seen several miles out, as well as providing the visual cues actually on the runway when you're, actually when the plane is on the surface of the runway. So I think you do yourself a disjustice when you when you to say about, well, 50 years ago and light sources have changed. I feel that they're, I feel the visual aids do a very good job, and the test has been that the most focused beam still, is still in the right place. You don't have a blind spot. You can see how focused the LED beams are, particularly in their application for aircraft stands, where the manufacturers of aircraft stand lighting are able to very, very precisely illuminate the required area for the aircraft to park, with minimum of wasted light, or as some people would see it, light pollution, which would have been caused by the traditional incandescent light sources, which basically, they're floodlights, whereas the LED equivalent floodlight is, very, very precisely picks out, the chosen area to conform with the standards and to provide the, the illumination that is required according to the standards. So,
effectively, what you can do with the LED is what you could do with a tungsten light source. If you made the light effectively a projector, and then you masked off the angles to the angles you want, and then you get a sharp cutoff. There are military applications of that where you floodlight the piece of tarmac you want and not bits you don't want.
Oh, I did that on the back, Tony, on the back of frigates, if you remember, the floodlights, and then I had to I used to have to put these little aluminium plates in and cut them off to the correct angle, so I cut off the light.
But that's not very efficient in the use
not very efficient
energy,
at all.
but that produced the same result. You can do it, but the LEDs, you can, as Robert says, you've got a much better chance of doing it much more efficiently, because you can have sharper cutoffs and so on.
Yes, I remember those days on the back of on doing them on the frigates, for the flight deck of the helicopter landing on a frigate, and the way we used to have to produce the floodlighting and the area, etc. And that includes
nothing more. That technology is nothing more, in fact, than the spotlight you have in a theatre. Correct.
But that's basically they were an outdoor variation of them, weren't they?
Yeah.
Yes.
Right, so we're getting we'll give another 10 minutes. We're already over time, but there's a number of questions coming in here. So Nick is asking about, suggesting that there might be a case for reducing the towing angle on high intensity runway edge lights, and also potentially what additional lighting is asking may be used to enhance a high intensity threshold, whether displaced or not. I've not seen that question before, but I would guess, I mean, I would want to, I mean, we're assuming that we're including a wing bar in the light, in the threshold, wing bar lighting.
I think the key issue about threshold, when you displace the threshold, then to enhance the threshold, which is being now displaced down the pavement, is the recommendation is to add wing bars, you know, for more conspicuity of that
Okay.
aspect. So there's the key issue, and what I think Nick is saying here is that do we need to then change the intensity levels, because the current intensity levels for a threshold green light, remember, it's when we're looking at light, we're talking about white light, aren't we? And then there's a reduction of light according to color, traditionally, and
Yes, but that's a reflection of the practicability of the specifications rather than the ideal. And there was a lot of that 50 years ago. The only way really you made your threshold and your runway end lights was the same technology as your edge lights, and then you then put a green or red filter
in,
and
yes.
got 20 or 15%, and of course, logically, ideally, your threshold and your stop end should be of the same intensity as your edge lighting, because it's
the threshold intensity is 10,000 candela, the same as the edge, but I agree that the red runway end is only 2,500 for high intensity light, which is a reflection of the filter. But yes, with LED lighting, one thing we see is that there's no limitation in intensity such that the red lights now, particularly on the runway center line, consistently massively exceed the standard, and to the point where you could actually they risk failing the standards specify 300% limit on a intensity for lighting, and of course it's very easy to exceed that for the red centerline lights. Because
this is the nature of changing from tungsten halogen to LEDs.
So that's something that needs to be addressed. I agree. Look, we're running short. Go on.
Just to say, I would challenge the idea that you increase conspicuity by putting wing bars in if you've got display threshold. Having done a lot of fog flying and landed in category 3 conditions, I can assure you that in the case where it really matters, your eyes are much focused around the approach lighting center line, and you just see a green bar go under the cockpit coaming. You won't see the wing bars. They're too far out of your 2 degree field of view, which is where you stare. It's only 2 degrees wide. When you're about 500 feet from the threshold, you don't see the wing bars, sorry, unless you deliberately set up a scan, and you won't at that point.
I think the standard though, Tony, when we're going back to the standard, you're quite 100% correct when we're talking about, the lower visibility conditions.
Yeah.
Correct. But we remember with lighting, then the visibility, the visual aid, we are talking about standard, conditions in excess of 550 meters, meters or whatever.
Yes, but
so you're quite correct. You're quite correct in what you're saying. The lower the visibility, then of course the effectiveness of being able to see the lights. It's the same subject when your specialist subject on the PAPI, where people say, well, should you have, do you need a PAPI in category 3? Well, the reality is you're not going to see it, are you?
No, you're not. No.
But it still has to be there,
for non-precision approaches and what,
Correct. Yeah.
Anyway, Robert's got some other questions.
Yes, I'm just thinking that possibly what we should do is carry the questions over to the next to the next webinar when we're continuing with the case studies. And we will put these
Good.
answers
Yeah.
first, because there's some very good questions here. All the questions are good, and we really want to give them our best answer. And we're running over time, and I know that a lot of you have got other commitments because I can see the numbers are dropping. So we'd like to address these to the whole audience. So if I can thank you all for your contribution, well, Keith, Tony, Sue, all for participation and contributions today. Damon and Felicity, without which this would not be possible. And of course, the audience for your contribution, for participating, for your time today and joining us. We really appreciate it. The next webinar is Airfield Lighting Maintenance Best Practice Part 2 on Tuesday, the 30th of May. We will start, I promise, with finishing off next questions and all the rest of the questions that we have here, which we won't have time for today. Also, you will be able to catch up on today's webinar if you come onto TMS Training Solutions. Hopefully tomorrow we will have the video online. Thank you, Damon. And so thank you very much all for your participation, and we look forward to seeing you all on the 30th of May. And until then, best wishes to you all, and in particular, Tony, very happy birthday. Thank you.